Okay, we're factoring. So yeah, let's first review factoring trinomials, section 6.2. So trinomials, right? Three terms, and there's two cases. So the easier case is when the coefficient of x squared is 1. Okay, so just x squared. And it's a bit harder when a is 2 or 3 or any other number. Then we need the AC method. So let's look at the easy case first. Yeah, so here it's just 1x squared. Okay, you could use the AC method here, but there's an easier way. So all we're looking for are two numbers that multiply to give C. So multiply to give the number on the end, and they have to add up to give B, the number multiplying x. Okay, so we'll see why that's true. But this case is easy. Yes, so we have to just work out two numbers. They multiply to give negative 35, and they add to give negative 2. Yeah, there aren't too many ways to break up 35 as a product. So 1 times 35, or 5 times 7. Yeah, we're looking for negative 35, so one of these should be negative. So yeah, either negative 5 times 7 or 5 times negative 7. Those are the two options here. And 5 times negative 7, that does give the right sum as well. 5 plus negative 7 is negative 2. So those are the two numbers we want. Yeah, so 5 here, negative 7. And so yeah, just put those numbers in as the factors. So it's x plus 5 times x minus 7. Yeah, and the reason it works is, yeah, if you FOIL this out, so you're getting x times x, so that's just 1x squared plus 5x minus 7x, the outer and the inner, and the last terms, we get the right product. Okay, so this is quite easy. When it's just 1x squared plus bx plus c, then you can factor like this. Let's review the harder case. So example 2, you see the difference. So now we have, instead of just x squared, now we have 3x squared plus 5x plus 2. So yeah, now we do need the AC method. We can't do this question like we did this first one. Okay, so how does the AC method work? Well, yeah, so here A is 3, B is 5, C is 2. So the method says to first work out AC, so A times C is 6, and also write down B, which is 5, and just like similar to here, now we're looking for two numbers that multiply to give AC, and add up to give b. Yeah, 6. 6 is 1 times 6, or 2 times 3, or -1 times -6, -2 times -3. But the two numbers we're looking for, yeah, they should add up to 5. So 2 and 3 are what we need. Okay, so again, yeah, that was fairly easy. We didn't need to play around with signs. Okay, so yeah, the answer is not x plus 2 times x plus 3. There's more work to do. So now we use, so b is 5. So 5 is 2 plus 3, so we're going to split the middle term. Okay, so this 5x turns into 2x plus 3x. And why is that useful? Well, now we can factor by grouping. Take out the greatest common factor from the first two, and separately take out the greatest common factor from these two. Okay, so these two have an x in common. That's the greatest common factor. Factor out the x, you're left with 3x plus 2. Greatest common factor from these is 1, right? They don't have any factors in common, so the best you can do is pull out a 1. So we're getting x times 3x plus 2 plus 1 times 3x plus 2, so that's x plus 1 times 3x plus 2. All right, so those are the factors. And yeah, good to check. So x times 3x, that's 3x squared. 2x plus 3x is 5x. And 1 times 2 is 2. So foiling this out, we do get the right answer, or we get the original trinomial. If you foil out your answers and you don't get the original, then that's just telling you made a mistake somewhere. Okay, so this is just a quick review of the two factoring trinomials, the easy case and the harder case. Yeah, just a note here. So if you put in y's, so the same thing, but 3x squared, change this to 5xy plus 2y squared. So putting in y's here, we can also factor this with the AC method in exactly the same way. So this 5xy splits into 2xy plus 3xy, and then factoring this by grouping, still a common factor x, but if you factor that out, now it's 3x plus 2y. This time, these two have a common factor y. Pull that out. Y times 3x plus 2y, so yeah, we get these factors. So really, just the same as the first case, but we're just including y's. Okay, so if you have two variables like this, then it just factors the same way. You just need y's. Okay, so that was reviewing trinomials, but let's look at other factoring techniques. Yeah, there are two special products we'll look at in this section. The first one is called a perfect square trinomial, and it's we can get away without using it, but it does give a shortcut. So it's quicker when it works. It's quicker than the AC method. Okay, so let's look at this. So example 1, factor this. Okay, 9x squared plus 42x plus 49. Okay, so yeah, we could, we have a trinomial. We're in the harder case. It's not 1x squared, so we could do this using the AC method. But you can see if you multiply a by c, so you're getting 9 times 49, so these are big numbers. Okay, so we'd like to avoid using the AC method if we can. So there is another way to do this particular one. So the idea is to look at the first term and the last term. If they're both squares, if they're both something squared, then we might be in business. And yeah, so 9x squared, that's 3x times 3x. 49 is 7 times 7. Okay, so that's telling us that this might be a perfect square trinomial. The last thing to check is for the middle term, is it twice this times this? So is it twice 3x, what you needed to square to get the first term, times what you needed to square to get the last term? And that is true here. So 2 times 3x times 7 is 42x. So that's telling us that, so yeah, we have a 3x and a 7. So if you square 3x plus 7, that's 3x plus 7 times 3x plus 7, then you're getting the 3x's squared. That's the first term. You're getting 7 squared from the last term, and from the outer and the inner, you're getting 3x times 7 plus 3x times 7, so twice that combination. Okay, so we factored the original trinomial. It is a perfect square. It's 3x plus 7 times 3x plus 7. Okay, so yeah, maybe that was confusing, but this is all just based on if you square the sum of two things. So if you have a plus b, all of this squared, well, if you FOIL this out, you get a squared plus ab, that's 2ab, plus b squared from the last. Okay, so this is the identity we're using. If we can match what we're trying to factor to this, okay, so if the first guy is something squared, the second guy is something else squared, and the middle term is twice those two somethings, then it's the trinomial factors into something squared. Okay, let's see another one. Oh yeah, and you can adjust the sign in the middle to make the middle term negative as well. Okay, so how about this? 81x squared plus 36x plus 4. So yeah, hopefully you're recognizing these perfect squares. So 4s, 9s, 16, 25, 36, 81. So 81x squared is, that is a square, that's 9x, quantity squared, so 9x times 9x gives you this. 4 is certainly a square, 2 squared. Okay, so now, do we have the template we're looking for? Well, we have to check the middle. So do we have 2 times 9x times 2 in the middle? Okay, this is 36x, and yeah, that's what we have. Okay, if the middle was 35x, then this would not factor as a perfect square. Okay, so everything has to match. Okay, but this is the right middle term, so this thing does factor as 9x plus 2 quantity squared, and you can check by foiling. Okay, one more with a negative. So yeah, you can see this is 4x quantity squared, this is 5y. In the middle, ignoring the sign for a second, it's 40xy is 2 times 4x times 5y. Yeah, that's 40xy. But we need to put in a minus sign between them this time to get the minus here. Okay, so if you FOIL this out, you'll get this one. All right, so these are trinomials that look like this are called perfect square trinomials. Yeah, they really are a special case, but it's just a handy trick to remember to avoid. The other way to do this is with the AC method, but difficult here with these big numbers. All right, so that's our first special product. Second special product is called a difference of squares. Okay, let's start with the identity this is based on. Okay, so it's just a slightly different combination. So instead of a plus b times a plus b, now it's a plus b times a minus b. So the sum of a and b times the difference, a minus b. What happens if you FOIL this out? Well, from the first two, you get a squared. From the outer combination, that's minus ab. From the inner, you get ba, which is the same as ab. And the last two give minus b squared. Minus ab plus ab, those cancel, so we're just left with a difference of squares, a squared minus b squared. So turning this around, so if you're starting with something like this, then it factors right away. It's just, so yeah, something squared minus something else squared. It's the sum of the two things times the difference. Those are the factors. Yeah, it's not very obvious, but yeah, this does factor like this. So this is the next pattern to remember. So whenever you see the difference of two things squared, then yeah, you should think of this, breaking it up like this. So here, example 1, x squared minus 16. Well, this is certainly a square, x squared. And we can recognize 16 as 4 squared. Okay, so here we're trying to rewrite it like this. Yeah, we need an x to go here and a 4 to go here. Then it matches. Okay, so instead of a we have x, instead of b we have 4. So the factors are x plus 4 times x minus 4. So those are the factors. And yeah, if you FOIL this out, yeah, you'll get x squared minus 4x plus 4x minus 16. Okay, this one has got a bigger number. Yeah, well, this is a more complicated square. Yeah, we can recognize 1 as that's 1 squared. 121. Yeah, we can recognize that as 11 squared. So rewriting this as a difference of squares, it's 11x squared minus 1 squared. And so here a is 11x, b is 1. So for the factors, we need the sum times the difference. Yeah, so once you see a few of these, it's quite straightforward. So here's the, well, one way to make this trickier is, yeah, let's see. So this time we want to factor 8y squared minus 200x squared. Okay, the problem here is 8 is not one of our perfect squares. Yeah, we're looking for 1s or 4s or 9s or 16s. Also 200 is not a square either. Okay, so initially this doesn't match, so we can't write this as something squared minus something else squared. But there is something we can do. So we can first factor out the greatest common factor from these two terms. So yeah, that's something that you should always look for first. It makes your life easier, makes the numbers smaller. So certainly 2 is a common factor. We could factor out 2, but even better, so the greatest common factor is 8. This is 8 times 1. This is 8 times 25, right? So factor out this greatest common factor. What's left? So we're still left with y squared minus 25x squared. Okay, now we can ignore that 8 for a second, and yeah, just look at this piece. And yeah, this is something squared minus something else squared. Yeah, we need a y and a 5x. So this piece is y plus 5x times y minus 5x. Altogether, this factors, yeah, so now put the 8 back in. It's 8 times y plus 5x times y minus 5x. So yeah, that's an important idea. Yeah, any common factors, you want to take those out first from 2 terms or 3 terms or anything you're trying to factor. And just to mention, so this is we've been working on differences, x squared minus 4 squared. How about factoring a sum of 2 squares, so x squared plus 4 squared? So what are the factors for something like this? Well, in fact, yeah, it's not possible to factor a sum of 2 squares, so it has to be a difference. So if you see something like a squared plus b squared, that does not factor. Okay, yeah, it doesn't factor using real numbers. It does factor using complex numbers. We'll get to those later, but usually when you're factoring, you're talking about real numbers. Okay, so that's this section 6.3. Yeah, you can also look in the book, factoring special products. So yeah, more on these trinomials. And differences of squares. And yeah, they do some more complicated patterns too, but yeah, we're not looking at sums and differences of cubes. Okay.